Hi! In this video, I'm going to show you some cases where it might be fastest to solve the corners and the edges of the last layer rather than doing normal OLL and PLL. To use this technique, you need to know some corner algs, which you will know if you know CLL. These algorithms from the CLL set are fast and do not alter the edges at all. They only solve the corners in our 3 cycle. We are going to use that to our advantage to allow us to predict what edge algorithm that needs to be done after the CLL. We're going to use this strategy when you know that we have a 3 cycle of edges that need to be solved, because all of the edge 3 cycle algorithms are really fast. You can also have the U-perms, which show up if all the edges are oriented before solving the corners. And in that case, you can just solve normally. The main point of this video is showing the cases where solving the corners is good even when your edges aren't oriented. To know that you will be able to solve the edges with a 3 cycle after solving the corners, you need the following. Number 1. One of the edges next to the corner that is not part of the corner 3 cycle is solved. And number 2. Oriented or not, the other edge should not be the correct one. Okay, let me show you what I mean. Here's the first scenario. First, we recognize that we can use one of the easy corner algorithms to solve the corners. And we see that the orange-yellow edge is connected to its corner correctly, and that this corner is not one of the 3 corners moving in the corner algorithm. And last, we see that the other edge connected to the corner is not the correct one. It's yellow-red, not yellow-blue. This is the second scenario. The corners are the same as in the last one, and we also have the yellow-orange edge solved again. This time though, the other edge is the right one, but misoriented. When we solve the corners now, we will end up with a 2 flip, which is not good. If the yellow-blue edge was oriented and the last 2 other last layer edges were misoriented, we would also get a 2 flip, but back here. Here's the third scenario. Again, the corners are the same. This time we have an edge connected to its corner, though the corner is one of the corners which is moving in the 3 cycle. Therefore the edge is not going to end up solved next to it after doing the corner algorithm, and you probably won't end up with the edge 3 cycle. You can end up with an edge 3 cycle even when you don't have any edges connected to the right corner, because there might be a solved edge connected to any of the other corners after doing the corner algorithm. These cases are a lot harder to recognize, so you probably shouldn't bother with them. But how can you know what 3 cycle you're going to get after solving the corners? You need to study the patterns of the edge algorithms. If the second edge is oriented correctly, then you can know what case it is without looking at the other 2 edges, since the last 2 edges only can have 1 permutation. This is because the cube cannot have only 2 pieces that need to switch places. And you know that they aren't oriented. Again, this video is covering the cases where you don't have all the edges oriented. If they are, you will end up with an EPLL. If the second edge is misoriented, then you also need to know which one of the other 2 edges that is the misoriented one. Now I'm going to show you some examples. This is the first one. Here you can see that you can solve the corners with this algorithm and then the edges with this algorithm. This is probably smart in this case because this OLL is not that great, and you would have to do an R-perm afterwards, which also would be hard to predict. But here you can just do the corner algorithm and then the edge algorithm. For this one, we see that the corners are in Niklas, and For the edges, we see that it's this one, and this OLL is also not that great, so therefore this is probably a good idea. For this one, you can also cancel into the algorithm, which is real nice if you can see that beforehand. Here's another scenario. This one I think is especially good because this OLL case is really bad. So I see that the corners look like this and the edges look like that, so therefore I know both algorithms beforehand, so I just do them both. And there you have. Okay, so here's another case. This OLL is actually very good, but at least with my out, you will get a diagonal PLL from this angle. You could also do this, but you'll get a G-perm now. Okay, so I see that you have these corners and these edges, so I instantly know what corner algorithm and edge algorithm to do. Okay, and this is where it gets questionable. For this one, I can see that I have these corners and these edges, but it's also pretty fast to see that if you do the normal algorithm here, you will get a CP skip, and also this block would be here, so all this would be red, and this blue one would end up here, so then you can also know your EPLL, which will probably be just as fast as doing these two algorithms. Sometimes you could actually lose some PLL skips if you do this. For example, for this case, you can see these corners and these edges. But if you just do the normal OLL afterwards, you can pretty easily see that the corners will be solved. And also in this case, the edges also are solved. So you should probably not do this. For this one, we have probably the easiest OLL, the free ref. For the CP, I know that I'm gonna get an adjacent corner swap PLL, which could be pretty good. It could be a J-perm, or it could be really bad. It could be a G-perm. And also here you can just do the corner and then the edge algorithm, which will be 18 moves total. So doing free ref and then PLL would probably be more than that, but you can do it pretty fast because free ref is a really fast algorithm. But doing these two, it's probably not that bad either because you can see both of them at once. So in this case, I think both options are pretty good. So how often will these cases actually show up in your solves? For the corners, with the 10 algorithms that I've showed you, you can solve 40 out of the 162 possibilities for the corners. And for the edges, it's more complicated, but it's 8 out of 72. So if you multiply that together, you get 2.74%. So in about 2.74%, these cases will show up. Thank you for watching.